lost that. It's a girl. Get lost. Why am I not lost? Welcome back.
I have to combine these. I was gonna drop it right now.
Because I thought they had theirs on Tuesday.
I'm gonna do right at your off.
Oh, look how cute that is. That's very cool. Did you ever go down and get yours, or you're just out in your art room?
No, I already got it.
You're good.
Like, that's what I
I
do.
do wear wherever you want.
I've been carrying it around since third period.
Yeah.
I feel like I'm gonna drop it.
Wait, hold on. You're trying to leave it here till the end of the day.
I'm sorry. Yes.
Okay, then I'll put it somewhere safe.
Okay, I got two.
I'm gonna put it back in this back corner. I thought you just meant for the period, but not that I think anyone will break it, but I don't know if I can necessarily trust my.
I was gonna put it over there next to the fan.
I know, but like the pencil sharpener's there, and I can foresee it causing some issues. I'll just put it there, and then no one will touch it. And we can get it at the end there. Okay, welcome back. We'll go over Tuesday's assignment, Wednesday's assignment, and then we're getting into the due date. So if you want to open them up to go over your answers. This was, like I said, this was from Tuesday. Almost. And then you guys at home, same thing, if you have questions on any of it. Tuesday was crafting with X and Y intercepts. And then yesterday you guys started talking about point slope form. Or not point slope form, slope intercept form. Today we're getting into different form of an equation. For all week we're looking at different forms. Tuesday was standard form, where your variables were on both sides. You graph it finding X and Y intercepts. Yesterday you did slope intercept form, where you find your y-intercept, plot it, and then use the slope to make the next point. And we're getting into the second form of it today. So any questions on the assignment from Tuesday? With your lines? X and Y intercepts, plug 0 in for X, 0 in for Y, simplify it down. We're good there. Sorry I keep yawning, I don't know what's happening. Yeah, right.
For C, I got that y equals 2 and 2, but it's not 2 1/3.
That's right. That is a 2. Any other questions on that one? You're always catching my. See, this is why I shouldn't make my answer key first thing in the morning when I'm sleepy. Number 2 was your amusement park problem, where you had to write that equation in standard form. Again, standard form is when your X's and Y's are on one side. So $50 before 6. If X represents before 6, then it's 50X. $20 after 6. So if Y represents after 6, I can do 20 times Y. So 50X plus 20Y will give you the entire amount of money brought in, which is also 2,000. So then if we're graphing this, find your X and Y intercepts. When you're finding your X intercept, you ignore your Y term. When you're finding your Y intercept, you ignore your X term, and so up and down. So this one, and we got nicer answers than the one we worked on in class on Tuesday. So then I just plotted. I didn't write what my scale was here, but I just scaled this by hundreds. So my Y-intercept of 4, or my X-intercept of 400, I just counted over 4. My Y-intercept of 1,000, I just counted up to 10. I'm scaling by hundreds, so 4 would be 400. And then what does it mean? 400 adult tickets, 0 child's tickets, or 0 adult, 1,000 children.
I don't think I did that right. I'm a little confused with what I did.
Do you have it written out?
Yeah.
I don't know. You did. You just didn't graph it. Like that's right. But so here, that's your X-intercept. So you need to be able to see 400 on the x-axis and 1,000 on the y-axis. So you just scale by tens, which just adds 0, 7, scale by tens. And then you just plot that point, 400 times 0 would be there. So there's there. And then count right hundreds up here too, so your top line, or your 10th line can be 1,000. Okay. So you did the math right, you just picked a bad scale. Any other questions on the amusement park one? And then this one, you had to draw as many lines as you could. So some of them would work, some of them wouldn't. You should have noticed that I labeled them just so that it was easier to talk about when I'm going over it. So the only ones you would have been able to draw were A, B, and D. Because if I try to draw something that has two x-intercepts, it would end up being some form of a curved line. Same thing with your two y-intercepts, some form of a curved line. You're not going to be able to do either of those. When we're in the linear function chapter, so everything we're drawing has to be a straight line. So to be a straight line, you're hitting the x and the y-axis exactly once. You don't have to hit one of them. Like you can have something that just hits the x-axis, just hits the y-axis, but you cannot hit either axis twice. Otherwise, it will not be a linear function. Okay?
Why make a curved line?
What?
Why can't you just like put a line on, like from the two x-axes to each other?
Do you want to draw what you're saying?
Why can't you just connect both of those dots like straight together?
Oh, okay. So you could do that. So then it would be, so she's saying, what's it, color hard. So you could draw one straight here like this, but then it's not exactly two y-intercepts because so we're at the 2x. So if I go from here to here, I'm constantly intersecting the x-axis. So there's an infinite amount of intersection points there. This is being worded as exactly two, so it can only hit it one time and then one other time. If I draw it straight through, it's constantly hitting that line and intersecting at every single moment, which is more than two. That question is saying, can a straight line hit it exactly twice and only twice? Where that straight line is hitting it consistently nonstop. Rose?
So then why can't you just draw a line that connects two dots and not put an arrow at the end?
So that's what I have here, right? This is basically what you're saying.
Yeah, but it only connects two dots.
Right. But again, every single point on that line is intersecting the x-axis, no matter what. It's not going further and further, but every single line is touching. The way this is worded, exactly two, means it can only hit 2 points and 2 points only. This is hitting at negative, what am I at? 1, 2, 3, 4, 5. This is hitting at -5, -4, -3, -2, -1, all the way. And all of the numbers in between.
I know, but I have like 2 points right next to each other.
But then you still have, so even if you do 0 and 1, you still have 0.1, 0.2.
Okay.
There's all of those decimals that we don't talk about, but there's an infinite number of numbers in between two numbers. So you're still not hitting twice. And that was the same thing too. So you guys are thinking in terms of just strictly whole numbers. You have to remember that there are all those values in between two that still count as two numbers. I understand your question. Does that make sense?
Yeah.
Any other questions on that? I don't know why my undo button doesn't work. Oh, now it is. Okay, that was a good question. But yeah, it's strictly just the wording. So if it just said can hit at 2 points, then you could do that because it's hitting at 2 points, but also 3 and also 4 and also 5. But if it's exactly 2, then it can only hit twice and no more than twice. And the only way to do that would be your curved line where you're kind of bypassing all of those middle numbers. Curved lines aren't linear functions.
If it said just two x-intercepts, then will you be able to do just the one?
Right. So the word exactly is what's throwing that off there because that means precise, nothing more than 2. Any questions, other questions on that one? And then, so we had yesterday's assignment, which introduced you to slope-intercept form. So now slope-intercept form is a form of an equation where right away you can see what the slope is, you can see what the y-intercept is. So you plot your y-intercept, and then we know that the slope tells you how far up and how far over to move. So then I plot that y-intercept, and move vertically and horizontally based off of whatever that slope is. So for these first three, I first figured out what my y-intercept was, so it's at a value of 1. Then I figured out the slope by figuring out the vertical change and the horizontal change to the negative 1/3. So then your form for slope-intercept. What, you good?
I couldn't find the homework because it didn't say.
So your general form, why is not letting me write it down, is y equals mx plus b. M is your slope. This is your y-intercept. So as soon as you calculate and find what those two pieces are, you just throw them into that form of the equation. Are we good with 1 and 2? Number 3, we had to write the equation. So $8 per hour and then $5 for a helmet. My y-intercept is 5. My slope is 8. So I went up. I counted by 2s, which is why it might look a little bit different than yours. So I went up 8 over 1. And then what would it be for 2 helmets and 2 bicycles for 8 hours? So I found what one purchase would be. And then I multiplied it by 2 because there's 2 of them. You good with that?
I don't see the equation again, and not in the same graph.
So yours is different because you scaled differently. You counted by ones. 1, 2, 3, 4, 5. You just think I counted by 2s. Because I saw that the slope was 8, and I saw that if I went up, I was gonna fall off the graph. You got around that because you went down. So you did the same thing, yours only looks slightly different because you scaled by something different, but still right. You didn't do anything wrong. It's just different. I just counted by 2s, you counted by 1s. And just because I put a point here, your point still exists on my graph, I just didn't draw it out. But it's still there, like you put a point down here, I just put mine up here. So it's the same thing. Okay, we go with that. So now there are new notes posted. You guys at home, oh, there's more, sorry. So write an equation, horizontal lines never have a slope. It always just goes straight through whatever your y coordinate is. And then number 5, I wrote to try to do it using algebra. You didn't have to, that's kind of the point of what we're doing today. I was just interested to see if anybody could figure that out. But I also gave you that graph so that you could do it exactly like we did number 2. So my y-intercept was -3, so I came down to 3. I plotted the 0.45, connected them, found the slope, found the y-intercept, and plugged it in. But that using algebra part was just to see if you could do it.
Yeah.
But that number 5 is what we're doing in class today, how to go through it and with the algorithm. So are we good with that? Okay, so then, again, you guys at home can open up the new notes. You guys, so the top part, it says what we can do. So that's what we should be able to do right now. We should be able to write an equation for a line that has a y-intercept of -2 and going through the 0.46 if there's a graph. So we're gonna go through like how to sketch a quick graph just so that you can see if you don't have a nice piece of graph paper or a nice grid, how you can still figure it out. But this is everything we should have to know how to do right now. And then by the end of class today, we're gonna be able to do it without worrying about graphing it. So when I draw a quick graph, I just do my x and y intercept. I kind of look at my numbers. I have to see at least 6 on the y-axis. So I'm just gonna do 1, 2, 3, 4, 5, 6 on all axes. Try to be as evenly spaced out as possible, just so that your information is accurate. You're just doing a quick sketch just so that we can see what the slope is, because that's what we're looking for. So then we would plot what we know. I know the y-intercept is -2, so that would be my coordinate point down here. I know it's going through 4, 6. So 1, 2, 3, 4. I know I counted just up to 6, so I'm just gonna put it at the top. And then you're gonna connect it. Oh. Crooked because of my shadow, I can't see where I'm going. But it's just a quick sketch. Because we don't really need to see the graph, we just need to be able to see what the slope is. Because in slope-intercept form, as long as I know the slope, and as long as I know the y-intercept, I can plug it in, and that's my equation. So then if we're looking at this graph, and it is a little bit more difficult to count because we just sketched it, we don't have all of the blocks in between. But what is the slope of my line? So how far up do we go? 1, 2, 3, 4, 5, 6, 7, or 8? Should be 8. Oh, no, I miscounted a line there somewhere. So my slope has a vertical change of 8, and then a horizontal change of 4. So I count over 1, 2, 3, 4. Even if you wanted to think about it as 2 coordinate points, this is 4, 6. This coordinate point is 0, -2. So when I subtract it, 6 minus -2 is 8. 4 minus 0 is 4. So then our slope ends up being 2. So then we plug it into our equation. Y equals 2x. And then b is your y-intercept. So if my y-intercept is -2, I would say plus -2, but you like to use the least amount of numbers and symbols that you can. So it would just be 2x minus 2. So that was the main point of your notes from yesterday. You have a graph, count what the slope is, plug that in for m, figure out what your y-intercept is, add them both in. So are we good with that? That's yesterday. Yesterday was pretty easy. Today we're getting into how do we do this without drawing and sketching this big ugly graph. So for example 1, we're given a slope and we're given a point. I want to bypass this whole graph section to get to my equation. So again, we're writing it in slope-intercept form. So that means I need to know the slope and I need to know the y-intercept. What do I know already? Right off the bat for part A. Abby?
You have a slope of 3.
I know the slope is 3. So I know that my final equation is at least going to say y equals 3x. The slope of it is 3. I have to figure out what its y-intercept is going to be. We can take all of this information and substitute it into our equation so we can solve for what we don't know. Your slope is m. Here's your coordinate. 2 is your x value. 1 is your y value. I'm going to change the color so that it doesn't get all mixed up. So if we take all of that information, again, substitute it into our framework, my y value is 1. So 1 has to equal the slope, which is 3, times the x value, which is 2, plus the y-intercept. But we don't know what the y-intercept is yet, so we leave that as our unknown part. So we're taking everything we know about the line, plugging it into the equation of the line to solve for what we don't know. Because right now, what can I do to start solving that?
I got a question. Where'd you get the 1 from, the y?
So my coordinate point.
Okay.
It has a slope of 3, and it goes through this coordinate 2, 1.
Okay.
So that means when I put a 1 value, oh, I mismatched them. Is that what you're saying? No, I didn't. So when I put a 2 in for x, it's going to spit out a 1 as my answer. So I put my 2 in, it spits out a 1. I have to figure out what that extra number is here in order to make my equation true. Are you okay, Abby?
Yeah, I don't know. I had like doing 2 minus 0 over 1 minus 3,
So
and
you-
then adding it to y equals 3x. Because what is that to your line? Wait,
So this whole, your slope as a fraction would be 3 over 1. And you think like that could be reduced, so that could be anything. It could be 6 over 2, it could be 9 over 3. So there's a lot of different options that simplify that down. So in order to figure out what that extra value has, we take what we know, plug it in, because now we can just multiply this. 1 is equal to 6 plus b, and then how do you solve that?
B would equal -5.
Because we subtract 6, so then we get -5 is equal to b. So the y-intercept is -5, so I can say this. I think you're getting confused with the y-intercept and the slope. Because the coordinate point here is 0, -5, where you can do like 2 minus 0, 1 minus 3, or whatever it is. But your slope is just telling you how tilted your line is. It's not a coordinate point on the graph.
I think I was confused because when you check your workspace slope up there, you did the coordinate point minus the y-intercept, and I thought you were finding your y-intercept by subtracting.
So your slope just tells you how tilted you are. To do that subtraction for your slope formula, you need the y-intercept, which we don't have, that's what we're looking for. Were you okay on that one? So then part B is the same, only difference is more negatives and a fraction. Again, I'm gonna put a big circle around here, because that's always our framework. We always need to know the slope, and we always need to know the y-intercept. Right now, we know the slope is -1/2, so I can start writing my final answer. It's gonna be y equals -1/2 x. I just have to figure out what the b value is gonna be. So then again, what do we know? Slope is -1/2. My coordinate point is x and y. So then I plug that into the framework equation to figure out the unknown part. So my y value or my output needs to be 5. I get 5 by taking the slope times the x value, which is -2, and I add some unknown amount. Don't know what that unknown amount is yet, so we're solving it. So my first step is what? What's -1/2 times -2? 1. So 5 equals 1 plus b. So then what's b? First, 4. Subtract 1. Are we okay if I don't write down all of those steps? Like if I don't write -1, and I just jump to say 4 is equal to b. Now we've done it so many times, and there's simple equations. So that's my y-intercept. So then, since it's +4, we would just say +4. So that would be the equation of your line. So if you graph this equation, it's gonna have a slope of -1/2, and it's gonna go directly through that coordinate point. Try to do C on your own. You need a slope of -1, and it needs to pass through 7. 7, I'm sorry. Would anybody prefer to do it outside? It's okay. Just now, show you how to do something. Just trying to show you that. I said, does anybody, would anybody prefer to do it on the board instead of me just doing it? Just to change that up. So there's our basic form. So we need the slope, we need the b value. You know that -7 is y, my slope's -1, x is 4, and then I don't know what that extra piece is. Yeah. It's a weird sensor. So -4 times, or -1 times 4 is -4. You're gonna have to go up onto the white part. Yeah. So then add 4 to both sides, and we get -3 as the b value or the y-intercept, and then y equals your slope of -1, x minus 3. Perfect. You could also write your final answer. I know sometimes you guys get confused with the ones and the negative ones. Y equals -1 x minus 3 is the same thing if you write y equals -x minus 3. So a lot of times you won't see that -1. I keep putting it in just to get you guys used to it, but it would be the same thing no matter which way you write. If you show the -1 or if you don't show the -1, so it's the same thing. We feel good with that. Other type that we have, so this is if you're given the slope and you're given a point. In example 2, now we have, if we only have 2 points. So it's pretty much the same thing. We're writing our equation in slope-intercept form, y equals mx plus b. We need to know the slope and we need to know the y-intercept. The issue is that if I only have 2 coordinate points, I don't know either of those things. So what can I do to find one of them? I need to write an equation going through 3, 1 and 2, 4. How can I find a slope or how can I find a y-intercept? Right. So we have our slope formula that tells us we can subtract our y coordinates and we can subtract our x coordinates. So if we're given 2 points, we have to find the slope first. So if I subtract my 2 y coordinates, 4 minus 1 is 3. If I subtract my 2 x coordinates, 2 minus 3 is -1. So then 3 divided by -1 is -3.
You do.
Vertical change over the horizontal change.
So you do what, 2 minus 1? No, 0. Oh.
I mean, it doesn't matter. Like, if you do 4 minus 1 and 2 minus 3, you're gonna get the same thing as if you do 1 minus 4 and 3 minus 2. As long as you stay in the same order. Either your top number is negative or your bottom number is negative, but it's still gonna simplify into the same thing. You just don't wanna do 4 minus 1 on the top and then 3 minus 2 on the bottom. You just wanna stay consistent in your order. So that's the slope. So now once you find it, it turns into exactly what we just did in the other ones, because now we have the slope and now we have a coordinate, so we have to find the y-intercept. So this is just a little bit extra because you have to calculate the slope first. So on the previous example, we were given a slope and we were given a coordinate point and we had to plug it in. Now we're just given 2 coordinate points. You can pick either of them, it doesn't matter. I try to look for whichever one's easier. So if there's a lot of fractions or negatives in a coordinate point, I wouldn't pick it. But neither of these look, one doesn't look better than the other one. So I'm just gonna pick my coordinate point of 3, 1. And it doesn't matter. Like I said, now we're just going through the same steps we did on the other page. So plug it in, my y value is 1. My slope that I calculated is -3. And my x value is 3. I'm looking for the y-intercept. Again, I could have just as easily picked 2, 4. Gives you the same answer. Like, but then the only time I pick one over the other is if one is all positive. I'd rather look at positives than negatives. If there's fractions in ones, I don't want to do a bunch of math with that. But it's going to give you the same answer. So we get 1 is equal to -9 plus b. So then you get a value of 10. Do the same exact thing if you plug in the other route.
So then we rewrite,
Right, so then you still need your final equation, because that's the whole question. What is the equation? So then your third step, I'm gonna get another color. Just keep everything separate. So step 1 in purple, step 2 in blue, step 3 in pink, is to take your slope, take your y-intercept, and plug into your final equation, which is just rewriting what we know. So -3x plus 10. There's just that extra step at the beginning where you have to calculate your slope. So then try to repeat. Find your slope. Step 1. Plug in a slope and a coordinate point for step 2. Rewrite your final equation for step 3. So find your slope. You should get 4. Does anybody want me to go over how you get a slope of 4? Anybody at home? Because I can look. I came around here and I saw everyone here had slope of 4.
And 6, let's do 4.
So then your second step, take your slope, take your point, plug it in. So anything, again, not one looks better than the other. So y equals your slope times the x value plus b. -2 equals, what did I do? -16 plus b. Add 16 to both sides, and we get 14. Okay.
Yeah, I think I messed up on that.
Because I was like, this is not what I just saw on Rose's paper. I'm like, what happened over here? It's just a little mess up. Okay, so then final equation, y equals your slope times x plus the y-intercept. Any questions on just the algebra portion of it? I'm only going over the next problem. We're skipping the second one. Just to familiarize you guys with a word problem, because you do have some word problems in your homework. But so we just want to look at the 3A. Draw that table in, because it's not given to you. So it says the table shows the number of flights in the US from 2004 to 2008. So add this table in, because it didn't copy over onto your paper. So we have from 2004 to 2008, we have the number of flights in millions. So 9.9 million, 10 million, 9.7 million, 9.8 million, 9.3 million. Then we're going to take that data to write an equation that we can use to predict the number of flights if it continues to decrease at the same rate. So if there's a constant pattern in there, we're going to find the constant pattern to figure out the estimate of how many flights there are in 2020. This is a little bit dated. This is from your textbook. So it's mainly pulled from before you guys were even alive. And then we're looking at to see how accurate it might be now. And then depending on time, we might have a conversation about if it's right or why it might be wrong in the current conditions particularly. But if we need to write an equation, we're in the form y equals mx plus b. So I need to find a slope, I need to find a y-intercept. So if I'm given this table, and we need to find a slope in the table, this is just a different way to organize a set of coordinate points. If I look at my last coordinate point and my first coordinate point, just because we're estimating, so I want to pick my numbers that are furthest apart because it's going to give me the best estimation of the data than by picking two that are close together. So I'm picking my first coordinate point and my last coordinate point. I want to find the slope between them, so subtract the y coordinates. So we're going to do 937 minus 997 over, what's that change in the x values? From 2004 to 2008, what's that change? 4. So then we would subtract 937 minus 997. What's our vertical change? If we subtract that out, 937 minus 997. So then when we divide it, we're going to get a change of negative 0.15. So our flights are decreasing by about 15,000 flights per year. So we're in millions.
Does that say negative 0.6?
Yeah, I don't know what happened to my pen there. It kind of just flattened out. So that's my slope. Again, a table is just a different way to organize your data. We pulled out the coordinate points. I found the vertical change, I found the horizontal change. We're modeling an equation. I already found my slope. So now all we have left to do is figure out what that y-intercept is. So we can find our y-intercept here. If we're talking in terms of years, we can kind of change what this looks like. If I call 2004 year 0, what would this year be? 1 year later is year 1, 1 year later is year 2, year 3, year 4. Okay, just to make the math easier. If I subtract these, 4 minus 0, I'm still getting 4. So I can kind of change the way I'm writing with years to be smaller numbers that are easier to work with. So now, if we're trying to write our equation, I have the slope, I can pick out a coordinate point. So let's pick out this one because it looks easy, 0, 997. My y value is 9.97 equals our slope times the x value to find the y-intercept. So same thing we just did, instead of looking at a coordinate point, we're looking at a table. And I'm organizing these numbers easier. The change still is the same value, but I'd rather work with smaller numbers. And now even so, this math becomes a lot easier because what happens when I multiply by 0 here? First,
The answer is 0.
right, so I can simplify it straight down to 997 equals b. So that's my y-intercept. So you also may notice that if you're given a table and you can see a 0 value, that y value is always going to be your y-intercept. So sometimes you might not even have to go through those steps. Your y-intercept always shows up when x is 0. So my y-intercept is 997. So that means my equation, I found my slope for part 1. I found my y-intercept. So there's my equation.
How did you determine which one was the x value and which was the y value?
In a table, your first column's always x.
So like, how did you know which one to put in which column?
This is what this how the table was written. I pulled this from the book. And if you think about like the number of flights depends on the year. So this is your independent value, this is your dependent value. Time's gonna keep going on no matter what. Your calculating depends on what year you're looking at. So this is your input, that's your output. The second question then says, use our equation to estimate the number of flights in 2020. So all that means is take a value and plug it into the equation. X is our years, Y is our flights. So if I'm estimating the number of flights in 2020, keeping in mind that I didn't use in terms of thousands, I just used year 0, 1, 2, 3, and 4. If it's the year 2020, what am I gonna plug in for X? If 2004 was year 0.
16.
Right. So I can keep counting up. Year 5 would be 2009. Year 6 would be 2010. I'm just reordering the way that I'm doing it so I can plug a 16 in for X to represent year 2020. So we have Y equals and then you would just run through that. I don't remember off the top of my head. I think it's about 7.5 we get. Y equals 7.5 million. Okay. Keep in mind that you could have done this problem just using the values in the table. You could have kept everything as 2004, 2005. It would make it messy here because you would be multiplying this by 2004. You would be plugging in 2020. I tried to just simplify it by changing the ordering because in terms of time, you can do that. 2004 to 2008 is still a 4-year change, so you can think about it as year 0 to year 4. It's all the same thing. Okay.
If you were to change 16 to 2020, would you still get 7.5 million?
Yeah, because that would change, this value would also change. Because I wouldn't have been doing times 0 here, I would have been doing times 2004. So that change in the y-intercept would fix this and work it out over here, because both of those values would be changed. So that's modeling your equation, and then when it says estimate something, like it did here, estimate the number of flights, plug in what you know. Okay? I know that problem ran through very quickly. Your homework is attached at the back of this. Try to do what you can. There might be some in here that are a little bit more confusing because we didn't get through too many word problems. You guys are coming back in here tomorrow, so if you're stuck on something, we can work on it. You guys at home, you can also sign in tomorrow to work on it. But that's all that means.
Fast class.
I know.
Press random.
What's that? Is that Caitlin? Sorry, I can't see the name. Caitlin.
I just turned in like the beginning of the class project.
The homework. Okay, I'll put it in for you. I've changed. All right.
Thank you.
You're welcome. Bye, Caitlin. Bye, guys. Bye, girls. Bye, girls. Parker, it's 8th period, bud.
Oh, sorry.
That's okay. It's okay.